Hi everybody, I'm just going to go through the unit circle stuff as quickly as I can. So if you come into your OneNote, into the first tab here, alright, so there's some videos that go through a little bit more detail. If you come down to using the unit circle section, there is a nice little link there. If you open that link up, it will take you to this PhET simulation, which will allow you to have a look at the unit circle. Now, the unit circle itself, we're going to be looking at some specific angles of, we're looking at 45 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then multiples of 180 degrees, right, another 30, another 45, another 60, 270 degrees. Going over to here, we're looking at another 30 degrees on, 45 degrees on. One complete circle is in fact 360 degrees. Now, you can either have this in radians or degrees, and we'll talk about that in a second. All right, so if I rotate that around, you can see the sine curve produces a nice wave like that. Now, one of the little things that we did when I was working with some students in class, I keep rotating and wrap that around, the angle keeps increasing. All right. Now, the notion of this app is to show you that this is a cyclic or periodic type function. All right, that's what this is. All right, and that can keep going around and around forever. Now, I'm just going to reset that. I'm going to go special angles. I'm going to show the labels, and I'll work in degrees. I think most of you are more familiar with that. If I go this way, notice that the graph goes that way. All right, so there we go there. All right, so we go back this way and we go right around here. All right, now, key thing is, if we look at cosine sine, this is my sine function. We're going to do all of our things for our sine function. So if you look at where the sine function's positive here, right, the sine function's positive, still above the axis here, and then my sine function goes negative, it goes below the axis. I'm talking about these values down here. All right, so we know that sine is positive for this first quadrant, that second quadrant. It's negative for these other two quadrants. All right, if I go and now choose cosine, this is my cosine graph. It's positive for that first bit. It's actually negative down here, it's negative down here, and it's positive here. All right, so that's my cosine. And my tan function looks really strange. All right, so we have these asymptote lines that occur. So we're looking at going around here, it's positive, goes off to infinity, then it's going to be negative there, it's going to be positive here, and it's going to be negative in that quadrant there. Now, come to your thing up here. We've got your unit circle now. On your formula sheet, you have this graph, this thing here, and you can actually use this in your exam. All right, this is going to be really useful. What this shows is the only trig ratio that's positive in this region here is, in fact, in the second quadrant, is sine. In the first quadrant, all of them are positive. In the third quadrant, tan's the only one that's positive, and in the fourth quadrant, cosine is the only one positive. So we can remember that by using maybe a saying South Australian and Tennis Club. Right, but you don't need to remember that because it's actually on your formula sheet, which is really cool. Now, I want to show you how I get all of these values here. Right, these values that are in the coloured bit. All right, I want to show you how you get those. So again, we'll come back to our sine curve. We'll reset that, labels. So when I look at going to 30 degrees, I get this value here. I get these two values, all right, which is, now the cosine is root 3 on 2, and the sine value is in fact equal to 1/2. All right, and I'll show you how we work that out in a second. 45 degrees, that is root 2 on 2, which we can also write as 1 over root 2. At 60 degrees, cosine is equal to a half, and the sine value is root 3 on 2. Right? And then at 90 degrees, the cosine of 90 is 0, sine of 90 is 1. So what we're trying to say here is the x-coordinate is in fact the cosine value, the y value is the sine value. You keep coming around here and you get these negative values for cosine, and you get positive values for sine. At 180 degrees, we know that cosine's negative 1, sine's equal to 0. Keep working our way around here. 270, we know that cosine's 0, sine's negative 1, and at 360 degrees, right, we know that sine is 0 and cosine's 1. Right? But you can see the nature of the graph as it goes around here. That's for cosine. All right. So I want to show you how to do this manually. All right. This is the thing that you need to be able to do in a test. Now you can use the sheet that I gave you, but if I said to you, theta is equal to 150 degrees. Well, I could also give you that value in radians as well. So if I put that into radians, my conversion in radians is in fact to times that by pi over 180, because pi radians is equal to 180 degrees. We could cross that out there. We know that what's common to that was 30. So 30 goes into there 5 times, and it goes into there 6 times. So I could write this as 5 pi on 6. All right. Now, where does that fit on a quadrant? All right, keeping in mind we know South Australian Tennis Club. All right, we know that 150 degrees goes from this particular axis here, which is 0, it goes around this way and it goes out somewhere around there. All right, so that's what we're doing, 150 degrees. Now, when we do these questions, we always want to drop that and make that with the x-axis. That makes this angle here 30 degrees, okay, 30 degrees. Now, we've got 2 special triangles on your formula sheet. And you don't, again, have to remember these, you have to know how to use them. So when we have 30 degrees, we have this special triangle 30, which is a 1, root 3 and 2. And when we have 45 degrees, it's a 1, 1, root 2 triangle. That's what I need you to write down. So the 30 degrees is opposite 1. We know 1 squared is 1, root 3 squared is 3, 3 plus 1 is 4, square root of 4 is 2. So that's just using Pythagoras. So over here, using that triangle, what I can say is the opposite side to 30 is 1. This side next to root 30 is root 3, but because it's coming from the origin, it's negative root 3, and then that side there is 2. Now, if I want you to write down what sine, cosine and tan are, we could say sine of 150 degrees is equal to the opposite side. We're using sol, car, toa. All right, so that's what we're using. So I could say sine of 150 degrees is equal to the opposite side over the hypotenuse. So that will be 1 over 2. Cosine of 150 degrees is equal to the adjacent side over the hypotenuse. That's going to be negative root 3 on 2. And tan is equal to opposite over adjacent. So that's going to be 1 over root 3, negative root 3. So that's going to be negative 1 over root 3. So if I now go back to my simulator and just check that out, so just reset that. Special angles, if I say to you sine of 150 degrees, it's come around to 150 degrees, which is there. It's saying that's equal to a half. Is that true? Yes, that's true. If I now do cosine of 150 degrees, it's saying it's negative root 3 on 2. Is that what we got in our graph over? Yes, that's what we got in our graph. And now if I do tan of 150 degrees, I get negative root 3 on 3. Now, what's that work out to be? Well, this is an interesting concept. if I have root 3 on 3, I can write that as root 3. Now, 3 is simply going to be root 3 times by root 3. So I can cancel that out, and that gives me equal to 1 over root 3. All right, so that's still the same answer there. So all of those match with my simulation thing over here, didn't it? Okay, so I could do that for any angle. I could do this for any angle. And so this circle is how I produced the following graph here. All right, so and that's on your formula sheet. So we're going to use those unit circle things there to try and actually do our angle. All right, let's do another one really quickly. All right, and so you get the idea. So number 2, if I said to you the angle theta is equal to 225 degrees. So I'm going to use my unit circle. All right, so therefore I know 225, that's 180 out to this point here. So it's going to be a little bit past that. And so that's the angle I'm looking at for. That would be my angle that I'm looking for 225. I'm just going to redraw this again, just so to make this a little bit easier for you. Now, we know that this angle here has to be 45 degrees. All right? So the 45 degree triangle that's on your sheet, and I'll go up to that particular sheet up here, 45 degrees means it's 1 root 2. So therefore, what I need to do is I need to use that triangle. So I'm going to make that side, I'm going to make that a thing. So it's going to be 1, 1 and root 2. Now, because this is the origin here, I'm going -1 in that direction there, and I'm going down 1, so it's -1, -1. All right, got the idea? Now, remember our South Australian Tennis Club? So South Australian Tennis Club. The only one that's supposed to be positive in that region is tan. So that's what we're expecting here when we do our next bit. So let's do it. So I'd go sine of 225 degrees is equal to opposite, which is -1 over the hypotenuse root 2. Cosine 225 is equal to the adjacent side, which is -1 over root 2. And tan 225 is equal to the opposite side over the adjacent. That's -1 over -1, which is equal to 1. And that's positive. All right, so again, if I now come to my little triangle thing, if I come around here, go to 225, saying sines root 3 on root 2 on 2, which is the same as 1 over root 2. Cosines root 2 on the same thing. And tan is got -1 there. All right, so that's a really neat way of doing it. Now, why do we do this? Well, before graphics calculators or before even scientific calculators, we had no way of doing this and getting an exact answer. All right, so if you actually do that on your calculator, you won't get an exact answer. You'll get, a decimal answer. So this is a way of getting exact answers for the angles of sine, cosine and tan of angles with 30 degrees, 45 degrees and 6 degree multiples. All right, so that's what you need to be able to do with these questions.